So, guys, the only difference, okay, of what we are seeing here is we're going to use the alternative difference quotient when we are actually given a specific c value. Notice my limit is now as x approaches c. It's not as h approaches 0, and I'm not going to have a bunch of h's that cancel out. Here I'm taking the function, subtracting the function value when I plugged in c, all over x minus c. Okay? So what this is going to do is it's going to tell us the slope at that very specific point. Okay? So, here's the first example I just want to talk about. It's f of x equals, that's not what I wanted. Ignore that. Okay. X squared plus 4x plus 3. Okay. So here is the function. What I want to know is what is the slope when x equals 2. Okay? So what this means is I've been given a very, very specific point, or I'm sorry, a value for x, so I'm going to use that as my c value. Okay? So if I'm just following what this says, it says take the function f of x and subtract that function when you plug in 2. Okay? So here's f of x. It's x squared plus 4x plus 3 minus, and I'm going to put parentheses around it just so that I'm making sure I'm keeping it all together, and hopefully you guys can stick with me. I'm going to square 2, so I'm going to get 4 plus 4 times 2, which is 8, plus 3, all over, if I'm just looking at this definition, it says x minus whatever that c value is. The c value here is 2. And don't forget, I want to say that it's the limit as x approaches 2. Okay? So as I look at this, I can see that I can simplify that right there. So I'm going to get x squared plus 4x plus 3 minus, this is 15, all over x minus 2. Again, it's the limit as x is approaching 2.